How's it going, everyone? Welcome back to another episode of Unwinding the Spool Podcast. My name is Andrew, and I am joined by one of my best friends, Will. And we are, of course, the 3D printing gurus, or as we like to think. And on this podcast, we like to talk all things 3D printing, all the way from the very basics to now we're getting into more advanced topics related to 3D printing or additive manufacturing. I thank you guys so much for either watching or listening into this podcast. We hope you guys enjoy it, learn a little something, and we spark your interest in 3D printing. If you've just gotten into it, or if you've been doing it for a while and you're just trying to learn a little bit more, then this is the podcast for you. If you haven't checked out any of our past episodes, definitely do so. We talked about a lot of great topics in the past, really 7 episodes that we've done so far. Some of which being talking about different CAD softwares we use to design 3D models to 3D print, talking about buying your first 3D printer, what to look out for, building enclosures for your 3D printer to help your print quality, etc. But in today's episode, Will, we are going to be talking about probably one of the most important topics, being an operator of a 3D printer, and that is the ultimate key to success with how to run a 3D printer successfully. And that is being a good troubleshooter. So to kick us off, Will, why don't you talk about what does it mean by being a good troubleshooter, and why is that important?
Absolutely. So I think there's a common misconception that 3D printers, whether you're buying an advanced 3D printer or a simple 3D printer, there's some level of they're just ready out of the box. And I'm here to tell you that, unfortunately, and just kind of dash your dreams here, it's not true. 3D printing is a very precise process that is based on a lot of factors that we can't even predict, such as environmental factors, how well you assemble a kit, all these kinds of things. And because of that, because it is such a precise process that is based around so many variables, you simply need to be really good at looking at a problem and solving it. And that means when you get a printer out of the box, you're going to have to take a look at, okay, this isn't printing good this way. This isn't printing well that way. This isn't doing the thing I want. And instead of, you can hop on to, call customer service for the printer you bought and try to just pellet them with this isn't working, you owe me something. I would say, take a step back, take a deep breath, and focus on solving the problem yourself. And so that's where we get into troubleshooting.
Yeah.
Troubleshooting is the art and practice of taking a problem you have and systematically reviewing the variables that you can change. In the Catholic Church, there's the prayer about accepting the things you cannot change and having the strength to change the things you can.
Yeah.
And so that is that is a good thing to think about when you're working with 3D printing, which is accept the things you cannot change and work on having the strength and the chutzpah to change the things that you can.
Yeah.
So I think a lot of it has to do, and Andrew, you can kind of add on to this, is kind of your tenacity to look at a problem, and instead of just going, this is a problem, I don't like this, this sucks, you need to take a look at that and go, what are the key elements I can start with to solve this problem?
Right. Yeah, no, totally. And yeah, I mean, you nailed it on the head, and as having the systematic approach of basically it's cause and effect analysis, right? And your print does something, or your printer does something, that's the effect. So now you're trying to backtrack and reverse engineer the process to figure out the cause. And I will preface, and you add to this or agree or disagree with me, but the key thing before you get into troubleshooting, so most printers requires some level of assembly. Some are more basic, some are more advanced. If you buy the Prusa kit, that obviously is way more intensive than buying a Creality, where you just have to assemble a few of the main components together. But your first step in this whole thing is to make sure your printer is put together well, and assembled correctly. Because if it's not, then you're going to be, chasing a rabbit hole that never ends. Because, if your printer's not built well. And I'll give a prime example of, so this past summer I bought my second printer, which is a Creality CR10S Pro V2, mouthful. But when I was putting it together, and then I got to the step of, how you have to level with those printers. There's 2 Z-axis rods, right? And you have to make sure that the X-axis carriage or track is level so that you don't have crazy bed leveling problems. Well, I was having issues like shimming it to the bed, and then that was because the bracket for the actual hot end that travels or traverses across the X-axis carriage or track was actually bent. So I had to send the whole printer back because I wasn't going to be able to fix that. Or if I was, it was going to be a mess. And so at that point, I was just like, I'm just going to send the printer back and get a new one. So just to start, make sure if you're having problems with your printer, you got to make sure it's assembled correctly from the get-go. If you bought the printer new, I'd say just the first thing that you're going to want to look out for is look for any shipping damage. Somehow mine got damaged, whether it was shipping, manufacturer, who knows. Just want to make sure there's nothing damaged. Or if you bought the printer secondhand off someone, you want to make sure that however they assembled it, it's put together well. And that might require some level of research and kind of know-how on what to look out for, how it's built correctly. And then from there, then you kind of eliminated a lot of variables that fall outside the scope of troubleshooting maybe not fall outside the scope, but, that it's a whole other realm if your printer isn't built or assembled correctly, would you say?
Right. No, I agree with you, and I think I'm going to yes and you here, not disagree, but yes and say that like that's part of this kind of system of troubleshooting.
Yeah,
I totally agree. I isolate variables.
Right.
So definitely isolating. Make sure your printer is assembled correctly.
Yeah.
Is isolating a good bunch of variables that really can screw with you in your ability to get your printer working.
Right.
And so I think that, again, and as you say, again, accepting the things you cannot change. If you have a printer that has things that are bent, you are going to need to send that part back,
right,
or the whole thing back.
Yep.
Inspecting for damage. I mean, the whole part of this is being diligent with it. So it's unfortunately not like getting a new video game console for Christmas and you can tear the box open and quickly assemble it and throw it up and you're good.
Yeah.
You gotta open that box, look at all the parts, make sure you look at, for example, my big old Tronxy X500 SA things missing bolts out of the box. So I had to go buy bolts that like I could replace it.
Yeah.
Because they were bolts that specifically helped keep the frame rigid.
Yeah.
And because it's such a large printer, having a rigid frame is hugely important. Otherwise, you get all these vibration problems.
Sure.
And I've been having vibration problems with my print. So I had to go back and go, okay, because I kind of did a quick jerry rig, like, I won't have all the bolts. I'll just have one bolt per and it'll hold it together. And I can at least get this thing running. And that didn't work. Like I had to go back and I had to put all the bolts in. I had to make sure everything was right.
Yeah.
And I think that you bring up a really good point of having the diligence from the minute you get the box to your first print is just as important as after your first print looking at what went wrong.
Right. Yeah, and for some people that's tough because, for someone like you or me who's been doing 3D printing for a while, we kind of know of some things to look out for. But for those that have never, this is their first 3D printer or the first printer of this kind that they've purchased, your ignorance is bliss, right? Like sometimes you don't know any better because you've never seen this before, so you think everything's all fine and dandy, and then it doesn't. So just pay close attention to any diagrams, watch YouTube videos of other people assembling their printer and say, hey, does mine look like different than that? Is that supposed to be that orientation or something? So just when you're putting that together, and it's unfortunate, but it's gotten better, I'd say, over the past 5 years. It's just the quality control of 3D printers. Most of these printers are coming from China, and as a lot of you people probably know, that sometimes quality control is an issue with things made in China. Granted, Prusas aren't made in China, and there's other printers that are made elsewhere. But even with any printer, no matter where it's coming from, you have the risk of shipping, and anything happening during shipping. So that's kind of where there's some level of variability with quality control in the actual manufacturing plant for these printers. So just that's kind of what we wanted to open with is, being a good troubleshooter basically is cause and effect analysis. And then the first step for any 3D printer is making sure it's assembled correctly. If you're building the printer yourself or if you're buying another printer from somebody else, or if you're like inheriting a printer, that's going to be one of the first things that you're going to want to do. So, Will, on the second point on kind of our agenda for today is talking about understanding the fundamentals of how a 3D printer works. Now, the caveat to this is that there's many different kinds of 3D printing technology. I'd say for most people doing this at home, we're going to be talking about fused deposition modeling, FDM, or fused filament fabrication, FFF. There are other types of printing, stereolithography with resin, liquid resin polymers, and then most people probably aren't doing powder bed at their home. But I think the fundamentals of how a 3D printer works in regards to FDM style. So you kind of want to kick the ball off with kind of those fundamentals.
Yeah, so I'm going to throw it back to one of our first episodes, which talked about the hot glue gun analogy.
Yep.
And you need to remember that these machines are pretty, I'm not going to say simple, but they're pretty rudimentary, which is they are a gantry system that moves things in a Cartesian coordinate system. Sometimes you have delta coordinates, but either way, you have something that moves, parallel to the Earth's surface, and then you have something that moves up and down perpendicular to the Earth's surface, and then you have a device that pushes plastic into a heated nozzle, and that plastic is melted, and it moves in according to a simple set of directions given by G code, as we call it, from a very simple computer controller. And it's just usually via a belt-driven system. So it's just belts around stepper motors that you can get just about anywhere. Belts on stepper motors, and those stepper motors are rotating and moving belts, and the belts move in the X and Y, and then you can move in the Z direction as well using screws. So these, again, because they're all such rudimentary parts, the basics of this, the calibration required is pretty intense. Because of the fact that we're using very rudimentary parts to create very precise forms of manufacturing. There is a lot of work that has to be done, even in the assembly of it. And once you're done assembling it, in the actual tuning of the machine, because the machine itself, even like a solid, like, again, I'm the fanboy of the Prusa system. Even in that system, it requires tuning, and it requires a lot of, it requires at least some work to get it to work in the way that you want it to.
Right.
Do you want to build on that at all? Or?
Yeah, no, definitely. I think you nailed it there when you talk about just understanding the core kind of fundamentals of the architecture of a 3D printer in regards to the different axes, the motors, the belts, the hot end. You have your extruder motor that's pulling filament into the extruder. So you just got to be aware of all those things, because once you're aware of all of those different components of the 3D printing system, that will then allow you to understand and backtrack when your print fails, and most likely you will have failed prints. Everybody does. If you don't have failed prints, I'd say you're a liar.
Absolutely. You definitely are lying.
Yeah. So just understanding like all the components that are, in this, some people are impatient, and sometimes people just want to plug it in and print something. And sometimes that works, sometimes it's good enough out of the box where you can get a print, but then 4 prints later, something's going to happen. So, there's a lot of variability, and I won't get too far off topic here, but I think that's one of the biggest reasons why desktop level 3D printing is it's taken off. It's gotten more popular, but that's why you're not seeing 3D printers in retail stores. Because,
exactly.
There's so much, tuning and know-how that has to go into these. People would be buying these things. They'd walk into the store and be like, ooh, that's cool. They'd buy it, and then they'd return it the next week because they couldn't figure it out, So,
exactly.
I'd say just understanding the what components build your 3D printer. There's some level of variation depending on the 3D printer you buy. Some have 2 Z-axis screws, some only have 1. Some have linear rails, some use belts, some don't, or maybe, I think they all use belts, but there's probably some level of variation when you're talking different price points of printers on how they're built and whatnot. But just understanding that the architecture of all the components and how they come together to basically just deposit melted plastic in a very precise pattern, layer upon layer upon layer. And so, like Will said, going back to the glue gun analogy, that's a great kind of piece to remember, and just think like, just have a glue gun attached to a computer-controlled carriage that moves left, right, forward, backward, up, down. So,
exactly.
Right. So, is there anything else we're going to talk about to that point? I think...
No, I mean, I think we basically covered it. I think understanding those basics, understanding that no matter what bells and whistles are put on top of that, it all comes down to that fundamental system.
Right.
And so you can have auto leveling, you can have sensors on it, you can have all kinds of firmware updates, you can have all kinds of ways the frame is more rigid than other printers, things like that. At the end of the day, it is a crane with a hot glue gun on it, and there is a lot of work that has to go in to make sure that that crane deposits stuff in the right place.
Yeah. Yeah, that actually just sparked what I was wanting to say was, I think just because it's so common, you know, if you go on any 3D printing forum or Facebook page or whatever, one of the most common things that people complain or ask questions about is auto bed leveling. And I will tell you, this is just my personal opinion, and you can say what you want, Will, but I think auto bed leveling is overrated. 100%. And the reason is because auto bed leveling, for those that don't know, so basically you have your build plate, right, and that has to be level relative to the carriage and everything where the hot end is on. The auto bed leveling system just goes and probes the bed in usually like 25 different places, and so then it'll pick up, or at least that's how it is for the Creality one. It varies from manufacturer to the printer, but then it just accounts for the difference in height of those different points. It could help possibly if you have a slightly warped bed, which happens with glass beds sometimes. But in my opinion, with auto bed leveling, kind of muddies the water with people and understanding how to level your bed truly with the 3 or 4 screws underneath the printer. That's true bed leveling, and I think you need to start by just learning that. Like, even on my Creality, the CR10S Pro V2 that has auto bed leveling, I've turned it off. I don't think it's that great of a system. I just do it by hand, and I've gotten experience enough to the point now where I can start a print, and usually I start a print with a brim on it so that I can get a little perimeter, or is it a brim? I'm blanking on the brim.
A skirt?
Skirt. Yeah, skirt. So it gives me time to see how the printer is depositing, and I'll turn the screws on the fly as it's going. And you just got to understand that, like, if it's too close or too far away and what to look out for. So anyways, that was just my little rant. I'm going to do another YouTube video on this on my channel, but I think auto bed leveling is so overrated, and that just, again, muddies the water with understanding the fundamentals of your printer.
Yeah, I think the thing about auto bed leveling is I'll add a little bit more of my spin on it is I do find it a useful tool, but only reason that you can make it useful is if you get yourself 95% of the way there.
Sure. And
so you really have to know what getting close looks like. So I'm with you. If you don't know how to do it by hand, it's kind of a detriment to rely on auto bed leveling.
Yeah.
But because you need to know what leveling that bed means and how your bed acts. And that is where, if you're like me and you use a lot of different materials and you're constantly dealing with changing things and you need to sometimes just crush the hot end into the bed for you to get any kind of adherence, you do sometimes just want a quick, like, okay, I re-leveled a little bit here. Let's just get myself up and running. But that's because I know that I got myself to 95% of the way there.
Right.
If you don't have experience with it, you won't know that you're 95% of the way there.
Yeah.
You won't know that, like, cool, I'll leave the rest to that little bit of editing that the machine can do within its own firmware. So I definitely agree with you. You probably, I would highly suggest not relying on auto bed leveling. Do the leveling yourself first. Then, honestly, also what I use a lot of the auto bed level checks for is just to check. I just use it to see if my leveling is okay.
Right.
So it's using the sensor distances to check. if I've got good placement of where I've adjusted, especially on the Tronxy system, which is a gigantic bed that definitely has kind of natural. It's just so big, it's got natural warping to it.
Right.
It's not rigid enough that it's perfectly flat.
Yeah.
And so there's that kind of system. I totally agree with you. You definitely shouldn't rely on it to solve your problems unless you can get it to like 95% perfection.
Yeah. I'd say like for any beginner, just if your printer has AutoBed leveling, turn it off and just understand the fundamentals of of leveling the build plate manually with the screws and the springs underneath the build plate. And then once you get a little more experience, then I think that's when it would be a good idea to maybe dabble into that. Because I see so many people like they'll buy a printer that doesn't have AutoBed leveling, and like before they've even racked up any hours of printing, they're already buying a BL Touch system and trying to retrofit it into the printer, and then they just get all the more confused than they were before. So my first printer, the CR10 V2, didn't have AutoBed leveling, and it just forced me to like kind of understand like the fundamentals of the build plate itself. Granted, if you're having a ton of problems, like it doesn't make sense. Like the bed is leveled fine in one corner, and then in the middle it's like completely different, and then in the other corner it's fine. So then you might have like a warped bed. So then that's maybe when an AutoBed leveling system might come into play. But I think a first entry level printer is a good one is one that doesn't have AutoBed leveling, and then when you're ready, you can either modify or buy your next printer that does have one.
Right, and I mean, even for me, the first printer I ever used was a Dremel a Dremel, what are those called? D20 or whatever?
Yeah.
The first systems they made that are pretty ready out of the box, but they still don't have AutoBed leveling at all.
Right.
And it is just, you have to use the screws and the system it has where it helps you with it, but like you have to use a piece of paper and the screws on the bottom to get that leveling right. And that really gives you a good fundamental understanding of what you're doing when you're leveling the bed.
Sure.
And so that way you become attuned to not having that, and that way when it's just you've got the AutoBed leveling, it's a helpful tool rather than the crutch that you're relying on to get good prints.
Mm-hmm. Yeah, totally. And I think that's a good transition point. So we're kind of going from talking about like just understanding the core fundamentals and the components that build the architecture of your 3D printer, the mechanical systems behind it, and I guess the electronic systems too. But even for me, that's difficult because I'm not super savvy with electronics, so I still have yet to learn a lot. But the mechanical systems and understanding that's usually the best first thing to learn, because most of the time electronics you should have an okay time with. Those are usually a little bit more robust out of the box. It's the mechanical part of the printer that has the problem. So we already talking about AutoBed leveling. So I think the first point on our next piece on the agenda here is like things to look out for when your print fails. Let's start with talking about the bed, right? So I think and it's funny. Every like holiday season, you always get an influx of people like with all these questions, and sometimes they're very obvious. Like as an experienced person who runs a 3D printer, you're like, oh, of course that's what the problem is. But that's okay. I mean, a lot of the people are buying or getting these 3D printers as gifts, and they have no idea how to operate them, so they run into the very basic problems. And I think one of the most common ones that I see with the bed leveling is the nozzle is just too far away from the bed. So if your printer is depositing material down and it's not sticking to the bed, like if it's trying to do a circle and it's doing instead like a square where it's not, the filament is actually picking up and dragging across the build plate and not sticking to the build plate, odds are your nozzle is too far away from the build plate. So you gotta use those bed screws and get that bed closer to the nozzle. And then I'd say on the flip side of that, if your nozzle is either scratching the bed and eating away at any type of coating that you have on your build plate, or it's just not depositing material at all, or it's depositing material that looks very thin, almost like see-through, that's a pretty good sign that your nozzle's too close to the bed. So you gotta bring that build plate down. So anything else, Will, that you could think of with build plate? I think adhesion maybe would be another good one, unless you had something else in mind.
Yeah, I mean, I was about to say, just kind of zooming out on those 2 points, is like I'd say the first step in troubleshooting, if you're a new to printing person, is what's called your first layer. That is your most important aspect of 3D printing to start with, that you should focus on, because you can't even figure out what else is wrong with your printer until you get your first layer down and a print keeps going.
Right.
So the thing that I always talk about is there's a couple of different tools, but when you're leveling, put a piece of paper underneath your nozzle. It should drag. The way I always like to describe it is it should kind of feel like when you when you scratch something off your tooth, it should kind of feel like that tension is on the paper.
Yeah, that's a good analogy.
That's what you're looking for. And the other thing is you're looking for, if you're seeing that, even if you're not like hitting the bed, if you're just not seeing anything come out, or it's kind of coming out in fits and starts and spurts and looks like it's kind of teardrop shaped or things like that, that indicates it's too close. If it straight up looks like it's just kind of like hitting it and dragging along and it comes off too easily, that's too far. And again, this is trial and error, and just kind of doing the best way to do is to do your first layer calibration by doing either like a calibration square that kind of does the outside perimeter of your bed, your build plate, or some kind of like snaking design that goes all the way around it. You can find prints to do so. If your printer comes with no calibration prints in and of itself, you can find them on Thingiverse or any of the websites we've talked about in the past. But most of the time, the printers will have some kind of internal system to start doing a first layer calibration. So just be looking for that first layer calibration, and really focus on you kind of want the happy medium where it's like a slightly squished line.
The first layer
it should look like a piece of, if you took a piece of spaghetti and just kind of like squished it flat on top and bottom, that's kind of what you need to be thinking about in your head, is what you're trying to go for.
Right. Yeah, you want that good first layer squished, is what everyone calls it. Right. So
exactly.
Like your first layer, if you try and look closely at the filament, as Will was kind of saying, you don't want that first layer to look like a cylinder, right? You actually want the filament to be kind of squished down and flattening out. That helps you with adhesion on your first layer.
Yeah, and also you want to be looking for making sure if there's a solid layer on the bottom, that as it's doing those kind of back and forth motions to create the solid infill, so to speak, that those lines are connected. You don't want to see gaps in between those lines.
Yeah.
So you want to make sure it's nice and solid, so there's enough squish that that you're basically completing when it's doing those passes, they're actually touching and creating a solid sealed surface.
Right. Yeah. And getting that first layer to print well is oftentimes the hardest, and obviously for many reasons the most important, because you're trying to get the plastic to bond and stick and adhere to whatever print surface you're printing on. So whether it be glass, whether it be the is it called Kapton tape or something, like the rough
Kapton tape, or there's a Tyvek tape, things like that,
or blue tape, so you're trying to get the plastic to basically adhere to something not similar to itself. From there, the next subsequent layers, the plastic it's easier for the plastic to stick to itself. So that's why the first layer is always tough. And that's why, as I kind of hinted at earlier, it's another good thing, a good best practice is, if you can get away with it with your print, in your slicer settings, always enable a skirt. So that basically gives your printer an extended perimeter that's not actually connected to the part you're printing. It's basically more time to see how well that first layer is going down before it actually gets to your part. So if there's any bed leveling problems or material extrusion problems, you can hopefully, once you get good enough at it, you can either recognize that, stop the print before you waste any more time and material, or you can change it on the fly and fix it before it gets to the actual part.
Right. And also by working on your first layer calibration, this is going to eliminate a lot of other variables that you need to look at when solving problematic prints. Because maybe you're just leaving, you hit go and you leave the room and you're like, oh, why am I coming back to all this spaghetti? And that's maybe just because the first layer didn't go.
Yeah.
It might just never have attached to the bed.
Yeah, no, and
that's definitely a big issue.
Yeah, so getting that good, gap between your nozzle and the build plate is very important. That gets you your first layer squish and everything like that. And then on top of that, I think the next thing to kind of look out for troubleshooting. So you can run into this depending on, environment settings around your printer. It could be material settings, calibration with the printer, tuning of getting your print to adhere to the bed, right? So
yeah, absolutely.
So what are some common things that, with bed adhesion that you would find as an effect, and then what might be the cause of like a bed adhesion problem?
Yeah, so some real common things are we've got like warping, so the corners or hard ends or just all of the edge of the print. So maybe you got a good first layer, but suddenly midway through the print you start seeing it starting to like bow up, and it's kind of pulling at itself as it goes up. And then this causes problem upwards where all of a sudden the layers can't properly go where they're supposed to, so you're getting layer cracking. So that's a common one. And that's usually due to temperature differentials. So that means your bed's probably not hot enough because it's just so cold that it pulls itself off. What's happening is the plastic above it is hot and the plastic at the base is cold, and that temperature differential is causing it to contract upwards.
Right.
And then that's kind of the first one that comes to mind.
And that also another thing that could play into that, sorry to interrupt you, but
you're good.
Is like we talked about in the last episode, if you're printing in an open air environment and you got a cold draft from a window, an air conditioning vent blowing across your printer, and it's causing rapid, uneven heating/cooling of your part, the material is going to want to pull up real fast, and you're going to get warping problems. So that's another thing. If you're having warping, try and get your printer in a consistent printing environment. The optimal situation being put it in an enclosure, in an enclosed environment, relatively about the size of the printer. Or if you can't do that, put it in an area of your house where the temperature doesn't fluctuate a lot. Don't put it near a window. Don't put it near an air conditioning vent. Try not to put it near a door, I guess, because anytime you open or close a door, if the one room is colder or hotter than the other, you're going to get temperature changes. So
absolutely,
that can cause warping problems. So, sorry, what were you going to say next?
No. I mean, you made me think of something else right when you were talking about that, which is also it could be that your cooling fan might be on too much. Yeah. Like if you're having poor adhesion, maybe your fan's going like right after, because usually it won't do cooling on the first layer. But if it's like right on the second layer, that fan is on 100% and just trying to cool the dickens out of that next layer. Well, that's still going to cause a temperature differential right there in the base layer.
Yep.
So make sure you're looking at your cooling settings. And, so like, let's say, I'd say first thing, you've looked at your bed temperature setting, you've looked at the ambient temperature, you're checking the environmental temperature to make sure that that's not the problem. You're still having issues, is check your cooling and make sure your cooling settings are pertinent to what you're doing.
Sure.
You're probably going to have to lower how much cooling or delay how much cooling is going on until you get a few more layers up, and that will help with the warping as well.
Right, and that's gonna vary depending on what material you're printing. So
absolutely.
PLA is the most forgiving. Usually, I think you run the cooling fan at 100% speed, but for like PETG,
that one you can cool.
Yeah, right. But for like PETG or ABS, you either turn the cooling fan completely off, or for me, I think when I print PETG, I put it about like 30-40% of the speed. That it can run.
Yeah, absolutely.
So, because it's dependent on material too. So just keep that in mind as well.
Yeah, absolutely.
And then I'd say the next thing, and this kind of all plays into each other. All the things we're talking about. If you're not having warping problems, and you're getting the worst, I guess, possible situation where your print is just popping off the build plate, and so then you get a part that's maybe 25% of the way printed, and then the rest of it looks like spaghetti. I've had that happen to me a few times. That's like your print is cooling to the point where it loses any, force of adhesion with the bed, and then just a little bit of kind of friction, if there's any from the nozzle moving over it on the subsequent layers, then it's going to pop it off the bed and push it away. So if that happens, check all the things we just talked about. And then I think, another thing that people do, like one of the most common things, you can just have adhesion promoters, right? So if you're having problems printing directly on the glass or whatever, if you're printing on glass, glass is a very smooth surface, obviously. So, as some of you want a rough surface to help with adhesion, just like when you're painting something. That's why you sand something first. So if you're printing directly on glass and you're having that problem, try an adhesion promoter. Common things are blue painter's tape. That works wonders. Another thing is it's kind of funny. You just think blue painter's tape. Well, I guess that's just enough of a roughness to help, get the film to stick well. On top of that, you could do things in addition to each other. You could do things by themselves. Another thing you can do is a glue stick. So just a simple glue stick, throwing down a quick little rub-a-dub-dub of some glue stick on the build plate. I will caveat that with sometimes that will add a kind of like a not so nice finish to the bottom of your part. So if you're looking to make sure your part has a nice surface finish on all layers, even the layer that's contacting the bed, the other thing you can use is hairspray. So you just do a quick little spritz of hairspray onto the build plate, and that's just enough stickiness to get that part to stick throughout the whole print time.
Yeah, and then there's also some special products like Magikoo or 3D Goo that you can buy in places like Matter Hackers.
Yeah.
This is a quick plug just because I love that product. Yeah. Magikoo, we're not sponsored, but please sponsor Magikoo. But we definitely, I've had a lot of success with Magikoo, which is kind of this roll. It's got a foam applicator, foam tip app. It's kind of this gel that you put on, and it doesn't leave like a residue on the print finish, but it promotes a seriously great bonding. And what's great about Magikoo and some of these other products is that it really helps with like any material. It helps not just with PLA or ABS, it helps with PETG, it helps with advanced materials of all kinds. And so what that really allows you to do is, even if your print bed and your temperature differential aren't doing great for your bed adhesion, that can kind of overcome some of those things, especially if you have really temperamental materials like a PETG or a TPU or something like that.
Yeah. So certain materials are definitely going to want adhesion promoters. Like I've only had very few successful prints just printing PETG directly on glass. Sometimes there's just materials that are just more temperamental than others. So things to look out for that. I think we've kind of nailed the bed part of. we've beat that pretty well into the ground as far as the bed part of the printer. I guess the last thing I would say, and this factor applies to many areas throughout the time of your build, all the way from the very first layer to the last, is don't run your printer too fast. If you're having adhesion problems or problems later into the build, if you're running your printer too fast, that's just more chance for it to mess up. So definitely slow it down. You can slow down the first layer, especially. Or you can slow down, like if you really get into the nitty gritty details of Cura, we could probably make a 10-hour podcast talking about all the settings on Cura. But
we wanted to go into each setting and how to troubleshoot.
But you can adjust the speed for like the infill, the walls, and so just really make sure you're not printing too fast. I usually, it depends on material again, but I usually stick somewhere between 50 and 60 for common hard plastics, and then if we're doing TPU, I slow it way down to like 20 or 30 even.
I was about to say, I usually for a TPU, any kind of flexible, I'm like at a 25 for sure.
Yeah. So that's another thing.
And so, sorry, this is also just to say, like, even me, a guy who has a lot of experience, I assembled my Tronxy, giant printer, and I was like, gosh, I just want to put on a bigger nozzle, speed this thing up, because these prints are taking days to do.
Sure.
I just want to get through this stuff. And so I try doing that, and all of a sudden, none of my prints are coming out great. And I'm going, man, this printer sucks. And it wasn't the printer. It was my impatience that was the problem. And so by just going back to the settings that come with the printer and just kind of settling down, putting back on a nozzle that works, putting back on all these things, I was able to, okay, cool, I got great prints out of it again. And they were still big scale prints, but they were great. And so sometimes you have to temper your want or your attitudes towards a project. Like for me, I was like, oh, I've got all these people with timelines and they all want things at a certain time. And you got to push back and go, well, look, this is how long it's going to take. Yeah. So that's something that also is always a good a good thing to think about.
Right.
When you're
That's one of 3D printing's biggest drawbacks is that it just takes time. If you rush it, it's that much more likely to fail. So you got to be patient. Patience is a virtue when it comes to 3D printing, both when you're setting up the printer and when you're setting the printer's settings. Don't be impatient and crank it up to 100 millimeters a second on the speed. Things aren't going to go well.
Absolutely.
So,
absolutely.
Yeah, it's a direct relationship of if it goes faster, your quality goes down, or inverse relationship. Sorry.
Absolutely.
So I think the next kind of big topic of troubleshooting areas when your prints fail is extrusion problems. So you want to kind of touch on some of to get us going on extrusion problems and like under extrusion and stuff like that.
Yeah, sure. So let's just go back over the basics, fundamentals. An extruder has this gear motor that is using these teethed gear motors to grab filaments, grab this line, and shove it down into a hot nozzle. Mm-hmm. There are a lot of things that can go wrong in that process. Yeah. I want to first go over a couple that happened to me with simple PLA machines. Heat creep. So this is when the heat that's being applied to your nozzle is somehow able to creep up into the other parts of your extruder. And that makes it suddenly at the gear motor where it needs to be perfectly cool and solid so that the teeth can grab it and push it. Now it's soft. And suddenly you're trying to put a cooked pasta noodle through a gear nozzle that just can't grab it.
You can't push a rope.
Exactly. It's push and rope now.
Yeah.
Can't do it. So that's a key one. So usually what that indicates is you have an actual problem with the assembly of your extruder.
Right.
So that's going back to our first point we made, which is look at how you assembled it.
Yeah.
And make sure that there's usually a fan and some kind of heat dispersal unit right there between the gear motor pulling or pushing that filament and the nozzle.
Right.
The second thing is to make sure that your nozzle assembly, all of the kind of fin assemblies or heat dissipating systems are in place and properly screwed on. Because there's all kinds of systems usually put on there, all kinds of pieces of hardware to just wick away heat from anything above the nozzle. Right. So that's the heat creep issue. That's something that happened to me on those Dremel 3D20s that I first started on. Once that fan that's supposed to be blowing cold air at this diffuser that allows the whole system to cool so that the nozzle doesn't actually have heat creep, once that fails, the whole system fails.
Yeah, and kind of to talk onto that point, I was talking about this with a colleague of mine and talking about like kind of the pros and cons of swapping a printer over to an all-metal hot end, right? Because that's what you need for certain higher level materials. And whether it be you're retrofitting your current printer or you buy a printer with an all-metal hot end, is an all-metal hot end, you're more likely to get that heat creep because you have an all-metal hot end instead of running that Teflon tube down through the hot end. So just be aware of that. If you're thinking of swapping to an all-metal hot end and you print PLA a lot, you might shoot yourself in the foot and run into heat creep problems. So just make sure your fans are running correctly. All the hardware is dissipating heat properly. Keep an eye on the set temperature and then the actual temperature that you're getting off the thermistor reading. Make sure that stays close to each other. It's going to obviously go up and down a little bit as the amps of the heater kick on and the fans kick on, but you don't want heat runaway also.
Yeah, absolutely. And that brings up a good point, which is another extrusion problem you can get is if you let's say you're trying to speed up your print, you increase the temperature so extrusion goes faster, and so you can increase your extrusion speed. Well, now when you're starting to push that, you might also be, when it's idle, like burning filament inside of your nozzle. Mm-hmm. And if you're burning filament, you're creating clogs. Yep. And those clogs get to accumulate until you finally just can't push any filament out of it. Now you got to unclog the nozzle.
Right.
So always be wary of going above the manufacturer specified, or going to the maximum end of the manufacturer specified temperature settings, because that means you're now getting to that end of we're going to start burning stuff.
Right.
Once you start burning stuff in the system, that highly precise, all of the electronics are calibrated based on a specific flow rate of material coming out of there. And now suddenly it can't achieve these flow rates.
Right.
Because it's got carbon buildup inside of your very tiny channel opening that allows filament to be extruded.
Right. So kind of speaking to that point, so clogs are a very common thing. So all those things that Will just mentioned can lead to a clog, burning filament, changing filament. So that's another thing that we run into. I run into sometimes at home and at work is if you change from a filament that requires a hotter temperature, so like PETG, I usually run at like 240C. And if we change back to like PLA and we're only running at 215, if there's any little bit of PETG still left in the hot end or nozzle, you're not getting it up to the point where it's going to melt and flow and you're going to get a clog. So that might be like the material's not burned in that case, but it's just because it's not, you have contamination of a material that's not melting completely. So it's also causing a clog. So you can get clogs from burned material, as Will said, from running too hot of temps or from switching over materials back and forth. So, that's just kind of a common thing to look out for. And usually, Will, you can add to this if I miss anything, but like when you have a clog, there's several things you can look out for. The most simple, you start your printer, nothing's coming out,
Right.
If you start your printer, nothing's coming out, or it's kind of just dribbling out a little bit. And then the other thing audibly to listen for is if you start hearing your extruder motor, which, as Will said, has those teeth that are grabbing the filament to shove it through the hot end. If you start hearing a clicking like a t t t, that means that there's too much resistance on the filament going through the hot end, and that extruder motor is now grinding into the filament and skipping. So that's probably one of the most common signs or effects that you can look out for clogged nozzles. And then the other thing too is like if sometimes your print will start fine and then you'll get a clog in the middle of a print. So or the print will completely finish, right? But then the print quality is horrible. Like I've had prints finish, but then it's like you could squish them with your hands and it's supposed to be a hard plastic. So that's what you call under extrusion. So that's where the printer isn't meeting that flow rate that the electronics are programmed to flow for. So it's thinking it's depositing, this many grams of material and going this fast, but it's not. So then you're under extruding, so you get thin, fragile walls, things that you can just kind of crush with your hands, basically.
Right. And in general, I mean, I won't get too deep into how to unclog a nozzle just because almost any manufacturer has guidelines on how to do that. But yeah, definitely if you're seeing a lot of under extrusion, I would definitely start to look at maybe the nozzle's clogged and go through the troubleshooting workflow to figure out what to do with the clogged nozzle.
Yeah.
In terms of over extrusion, so kind of going to the other side of extrusion, over extrusion, that's usually a programmable kind of thing. And that might mean that your extrusion multiplier is too high. This is what kind of overcomes or gets you the layer line width that you need. And so the machine may be overcompensating and trying to push too much material out at one time. It may also, again, mean your temperature's too hot and too much material. Again, you're screwing. This all kind of comes back to that flow rate, which is unless the flow rate is at the assumed amount that the computer is making, you're going to have weird prints.
Yeah.
You need to be in that precise flow rate. Otherwise, things like bridging and closing gaps and doing overhangs and all these things might have problems because now you don't have the flow rates that are expected to come out of the machine.
Exactly. Yeah. Yeah. So then it gets pretty tricky, especially with, if you go in there, and we've said this in our past episode when we talked about Cura settings, if you're just starting out, don't mess with the kind of preset print parameters. Try and stick closely to that and don't change too much at one time. Because if you're changing all these different settings and then you're trying to print, you don't know which thing you changed could be causing the problem. So if you're having problems, change one thing at a time and one thing only, and then try it again and see what happens and then backtrack. If that didn't fix it, revert that setting back to default and then change something else.
Yeah, and I would definitely also make sure you first, when you're troubleshooting, generally the settings in the machine have been tested. The settings in the Cura have been tested a lot, it's most likely your hardware and your build that are the problem. Because unless you're printing with some super experimental material and trying to do a super experimental way of printing, the thing that you've got going on in your desktop with PLA to create like D&D minis is not pushing the limits of the Cura set.
Yeah.
It is definitely like, make sure you really review what your build looks like and a lot of the hardware that's going into it, and make sure it's not nozzle clogging or you don't have too much tension on those gears. Maybe you got them pushed too close together, and usually there's a tensioner system you can adjust.
Right.
And so that would cause other issues with flow rate. So look at your hardware first before really delving into the software bit.
Yep.
For sure.
Yeah. And this kind of always goes back to making sure your printer is put together correctly. And as we said, one of the most common things with under extrusion or clog nozzles is skipping. So sometimes you might not have a clog nozzle, but that, as Will said, that tensioner spring on the arm that pushes the filament against that geared motor is too light. So you could increase the tension of that a little bit. Don't do too drastic of changes, but you could try that. And then I'd say, as far as like adjusting or trying to fix the hardware side of things before you start delving into the software. So before you go out and fully change your nozzle, and that's another good tip, is just have a bunch of spare nozzles on hand ready to go, because those are consumable pretty much. Before you do that, you can get what's called, I think they're still called drill bits, right? But they're just super small.
Tiny drill bits.
Yeah. So basically they have little itty bitty microscopic, they basically look like a needle. So obviously be careful, because I've pricked myself a few times with these things. And you run the temperature up of the printer, get it to the printing temperature, and take the filament out, right? So you're not shoving into hot filament. But then you can use this little itty bitty drill bit and kind of with your hand push it up through the nozzle to kind of clean it out almost. That hopefully will, you could hear popping and smell like things burning off, or you might get some stuff coming out on the drill bit when you pull it out. That's a good sign that you're hopefully clearing the nozzle from any kind of blockages. And then if you do have to actually replace the nozzle itself, which we all get to that point at some point, just make sure that when you screw down and tighten down the new nozzle, you do that completely, and you don't loosen other things, because that's another thing that can happen, is if you get little itty bitty spaces in between the heater block and the hot ends leading up to the heater block and the nozzle, you can actually get filament squirting out the sides. So if you get a weird blob of filament that didn't even come out the nozzle, it's because things probably aren't tightened down all the way.
Right. And I mean, this just goes back to looking at the manufacturer specifications and making sure that you've completed the build, reassembly, whatever part of the process you had to do to like replace your nozzle, get your hot end working again. Make sure you're really following the instructions given from your manufacturer or the extruder manufacturer if you like use a third-party extruder or something.
Yeah.
But make sure you really look at what part of the process, or all the parts of the process that you're needing to do to get that back to ship shape.
Right.
And I think that really kind of comes back to being a good troubleshooter is really understanding and reading the directions very well, and understanding how your printer is put together, and looking at the printer and looking at the hot end assembly and looking at all these things.
Totally.
Unless is there anything else you want to talk about extrusion? Because I have a couple other simple, silly things that I think are great troubleshooting.
No, I think extrusion, we've pretty much nailed it there, but I think there's some other kind of main overarching points. I'm sure we could talk for hours on troubleshooting, but talk to the points that you had in mind, and then I'll finish up on what I had in mind for this topic, or for this area.
Yeah, absolutely. So just a couple of quick things are, and these are more getting into Will's like stupid mistake things from his past, is check to make sure your filament isn't tangling. So if you're like, God, I'm having all these under extrusion problems, it may be that the filament's in a knot and like can't actually pull itself.
Sure. I just had
we called it all, my buddy Aldrin and I and Andrew and all the guys who worked on the some of these projects we had at lab at UC Irvine, we would call it hanging yourself. It was just kind of dark, but we would call it because we had a system where it would kind of go up and over, and that you could see them all. But they would literally sometimes tangle so bad and then pull themselves up off of the table, and they would hang themselves. And so we would call it hanging themselves. And so that's one thing that can definitely happen, and that's totally out of your control because that's just coming from the manufacturer. Yeah. Sometimes they're just tangled from the manufacturer of the filament.
So that you can avoid that by buy reputable brands of filament. I like Overture, eSun, Matter Hackers makes great filament now. There's plenty of good brands, so just make sure you buy reputable brands. And the other thing too is when if you're switching materials and you have a spool that's not completely used and you're storing that, make sure you fasten down the end of the filament line securely so that it doesn't tuck under itself, because then you're much more likely to get the tangle. This happens all the way from the very basic entry-level printers to at work the other week. We were trying to print this huge part on our Stratasys machine, and for those that don't know, a Stratasys, it's like an industrial level printer, probably a $50,000, $60,000 printer, and it was doing that same thing. The filament was getting tangled in the spool, and then it was that printer is smart enough where it knows if it's getting resistance on the thing, it actually pauses the print and stops. But it happened like 5 times, so we had to really almost unwind the spool, not completely, but to find that tangle and get rid of it. So, yeah, that is definitely a silly mistake that you can save yourself a lot of headaches if you just kind of be aware of that.
Yeah, and then another silly mistake that I've definitely made is make sure that you are not accidentally turning the power off to your printer. So if you're in a room that has a light switch and you're connected to the light switch and you go and you're like, cool, the print started, I'm going to turn the power off. Or I'm going to turn the light off as I leave the room. I've definitely been guilty of turning the light switch off, not thinking about it, and realizing that also turned the power off to my printer.
Yep.
And I come back hours later, I'm like, what the heck? Nothing happened. It doesn't even look like it did anything.
Yeah.
And that's because it didn't.
It was just off.
It was off the whole time.
Yeah, no, that's definitely... You can save yourself a lot of heartache, too, by making sure your printer is plugged into an outlet that constantly gets power all the time. So,
absolutely.
So kind of the last few points that I thought of, I think that are good, kind of just general troubleshooting, common problem points are... So the first being your belt tension. So a lot of printers, like we already said, their architecture is they use a series of belts to move the X, Y, and not usually Z-axis because that's usually a rod, but at least the X and Y are driven by belts. So if your printer, and if you're printing faster, this can especially be a problem. If your printer's changing directions and then you kind of get like layer shifts, or sometimes they call it ghosting too. So if you have like a hole feature and then, you kind of get these weird like kind of lines following the hole, that could mean that you have loose belts. So you have to tension your belts. That could be something for that. Have you ever run into that problem, Will?
Oh, yeah.
Okay.
Oh, yeah.
Okay, so I just wanted to mention that. Just make sure your belts are tensioned properly. If you're getting kind of swampy prints that, they're not precise and the layers literally look like they're kind of shifting on themselves, that's a common thing to look out for. And then I think kind of the last probably big point that we could end on for, points to look out for are stringing problems, right? So that's another very common entry-level problem is stringing. So you want to kind of go over what stringing is?
Sure. And so stringing is basically what happens, and this is kind of going back to our conversation we had about melt temp and flow rates. And so when you're printing and your printer does a big move, as in it's not actually extruding material, but it's going from a point where it was extruding and moving to the next point, there's still momentum in the system. Yeah. You still have material that was being pushed through, and it's now not being pushed through, but there's still a little bit of momentum in that system. And so there's still some tiny bit of melted plastic on the nozzle. Yeah. And as it moves, it kind of pulls it like taffy and then moves to the next spot. And it might be clear by the time it gets to the next spot. It might not even be clear. But what it's doing is creating this tiny string. And as it does that on every layer, you'll kind of sometimes get these walls of like strings all over your print. Yeah. And so there's a couple of key things. Look at your print temperature. Maybe you should decrease your print temperature. You might not need to be printing as hot as you are. Another thing to look out for is try retraction.
Mm-hmm.
That's usually a setting you can use. Try putting on retraction.
Yeah.
That way, it's actually what it does is it, instead of just stopping pushing, it actually pulls the filament back up a little bit and kind of hopefully sucks some of that extra plastic back up into the nozzle as it's traveling and then starts depositing again.
Right. Yeah. So common thing, if you're running into these problems, you'll likely see, like what Will said, like lots of little itty bitty strings across your print that kind of look like spider webs almost, or you'll start little like boogers, kind of like the unofficial term from like little boogers.
Yeah,
sometimes boogers. Burnt too, because there's sometimes a little burnt pieces of plastic. So yeah, check your temperature, check your retraction settings, and especially if, again, this comes down to material problems a lot too. So like PETG is going to want to string a lot more because it oozes. So if you have a material that oozes and like kind of wants to keep flowing even after the printer said stop pushing material out, it's going to do stringing or give you boogers. And TPU, so the soft flexible filament, that's another thing. So you're going to want to really, fine tune your retraction and temperature settings with the soft TPU filaments. A lot of people will say you can't print flexible filaments on a Bowden tube system, which just means that the motor that's pushing the filament is farther down the track instead of a direct drive where the extruder motor is right at the head. You can definitely print flexible plastics with a Bowden tube system. Anybody that tells you that is lying to you. You just have to tune your settings accordingly. So just make sure you look out for those things because, like Will said, as your printer's printing, it's wanting to shove the filament through a much smaller orifice than the diameter of the filament itself. So it's actually creating some level of pressure. So once the filament has pushed to a certain point, it's going to want to keep pushing because of that pressure. That's especially true with TPU. So, so that's kind of stringing and oozing. Very common problem for anybody that's just setting up a printer and tuning it. So I think that covers our bases. We're at an hour already, and I'm sure we could keep going talking about troubleshooting.
Absolutely.
But I think that's a good point to stop, at least talking about all the minute points to look out for. And again, like we've said many times now, just make sure your printer's put together well and make sure you understand the fundamentals and the mechanical actions that are going on, whether it be material melting, material extruding, bed leveling. Make sure you just understand that and understand your printer so that you know how to fix the problem if you're having problems. And then, Will, do you want to kind of just talk about, the best thing to do if you're starting out and you're just learning how to troubleshoot, how best to kind of learn from your mistakes or learn from... It's kind of
absolutely a big thing that Andrew and I did when we first started working, and Aldrin and a lot of our buddies on this print farm, 40 plus printer print farm. I mean, we'd never done it. We were like a year or so into our 3D printing experience at all. And a big thing is keeping a log.
Yeah.
It sounds super simple, but it's just keeping track of what's working and what isn't working. So, for example, we created this whole system of chemical baths to clean out nozzles.
Yeah.
And sometimes we were noticing a lot of the chemical baths weren't working. They just weren't doing what we needed them to do. Or we would notice a certain temperature or a certain speed just wasn't working. And it's really important to log all these things because you might just be repeating yourself if you don't do
right.
it. So log what's working, say, hey, this is what works. So for example, for closed loop plastics, when we create a profile for working with one of our materials, we share it with each other. We all try it out. And then we also log how it works, log why it worked. And that way, when we send it out to people and they have questions, we can be like, oh, it works because of this.
Yeah.
Or we did this, and this, and that's how we know it works. So definitely keep track of your successes, keep track of your failures.
Right.
And it can be something as simple as an actual handwritten journal. We had that for the first start in the lab. We bought these nice journals and had everyone date and log them. It can be like an Excel spreadsheet if you want to go crazy, It can be all kinds of things. But just kind of try to have a way to track the things that are working and track the things that aren't working.
Right. Yeah, so that way, if you printed something a week ago and it didn't work well or it did work well and you're trying to print something again, you can revert back to okay, what did I do last week that made it work so well? So then you can log what temperature, nozzle and bed, what flow rate or what speed did I print at, et cetera, and, keep track of all the different materials, because these things are going to, again, vary from material to material. Some materials are harder, some materials are easier, PLA being the easiest. So that's a good material to start with. It's the most forgiving material. So yeah, that's definitely a good point. I do that even to this day, of log my settings, just so I can look back and see, because if I haven't printed a certain material in a long time, and like, man, what settings did I print at that made it work so well? It's easier than, okay, here's where it's at. And the other thing you can do too, I think you can even save tuned profiles in Cura. So you can like name special settings, but I like to have it on paper. It's just easier that way. So.
Yeah, especially if you're like me and you got like tons of copies of profiles that say like just stupid. I'm not good at titling things, so it's just like the date and like ifs, and that's all it says. And I'm like, okay, well, what did I do on that day? Right. So I have to have something to refer to.
Yeah. So some type of journal or logbook, and you can even use that journal to vent about the frustrating days of 3D printing too.
Yeah, use it as your own personal, take a diary entry, take a moment, do some emotional.
January 23rd. I hate this printer. Just
I despise this. Why am I here?
So, that's a good practice to adopt if you're getting into 3D printing, or if you've been doing it for a while and you just want to be a little bit better. And the last point is just know your printer. Every printer is different. How it's built is different. Its features, its architecture. A Prusa is going to print differently from a Creality, Ender 3, and vice versa, and all the other printers, many printers that are on the market today. So, what might work for someone might not work for you for various reasons. It could be that their printer is slightly different. It could be that the ambient environment that they're printing in is slightly different. So it's going to vary from person to person, from place to place, just a little bit. So I think that's a good stopping point. This is a juicy episode, and I think it's an important one, because being a good troubleshooter, I think, is like just basically the key to success with 3D printing. It is the golden egg.
Absolutely. And just my final word on it is remember to, a good troubleshooter, the very basic idea of being a good troubleshooter is reduce the amount of variables you're changing, eliminate possibilities, and just keep going systematically, one thing at a time. Don't get overwhelmed. Don't change too many things. Just keep a system, record that system, and keep track of things.
It's kind of like experimental design or like scientific method. You're basically doing it. So that's going to do it for this episode today. I hope you guys enjoyed it. Thank you, especially if you made it all the way to the end. We greatly appreciate your viewer or listenership to our podcast episodes. Our podcast numbers are definitely growing, so we're excited to see that. We're very excited to keep doing these with you guys and share all of our knowledge with you all, and especially once we get into some of the more advanced topics and some of the kind of the cutting edge things with 3D printing. I'm excited to get into those episodes in the weeks and months to come. So thank you again so much. That's going to do it for this episode. Be on the lookout for the next one. And other than that, guys, we will talk to you later. Bye-bye.
Thanks, guys.